then you
Nice.
circle back down. And so like there's just so much artistry in this project done, and they're really adios mio. I have nothing to say. It's just magical.
Welcome to Kit Crashing, where we explore landscape architecture, tools like 3D, parametric design, and AI. This season, I'm joined by guest host and landscape architect Ishaan Kumar. Ishaan brings the challenges, and I tackle them live, using computational design and my plugin, LandKit, to create better workflows. Good morning, Ishaan.
Good
How are
morning,
you?
Chris. Good, good. Sorry for being late here. I had therapy today, so you're gonna get the Zen version of me, but also I had to pick up my nephew who was vomiting from school. My brother and sister-in-law are in Disney and with their two older kids. They have four.
Yeah,
And so I got out of therapy all Zen, and my wife called me, you gotta pick up Hado. So picking up Hado, now I'm here. But
yeah,
on the way here, I was thinking it's really great. I talked about this in therapy, just like how dynamic my career has become working, leaving the US. In the US, you're so programmed and wired to work at a firm and climb the ladder and sit, you go from office to office, or you stay at an office and you want to build that legacy of
yeah.
trajectory of 20 years. And moving to Argentina like crippled that, traditional career that I had in my head coming out of Penn. But it's been fun, and the first episode we talked about a project I did with Preston. I get to work with you, I get to work at local. There's some things, and before we jump into today's episode, I just wanted to pick your brain on that, and like how you've seen that growth personally, or that flexibility as a father. We're both fathers, that having that disposition for your family, for your kids, personally with Landau. I just wanted to take a second to reflect on that.
Yeah, yeah. I mean, having your own space to think and determine your own destiny is, you know, pretty amazing. And being able to say, what if I did this? Like, what if I created LandKit, or what if I, you know, helped these people with dog prosthetics? Like there's
Yeah.
all these weird things that
Yeah.
happen. Um, but it's good. I mean, I think there are times where it can be terrifying to sort
Yeah.
of, whether you're just simply running your own business or trying to figure out like what your actual career is while you're doing that.
Mhm.
It's very challenging, but I think it's a set of skills that is super valuable, especially today with AI and all the technology at everyone's fingertips. It's sort of like you can really create the career you want. Like
Beautifully
it's
said.
not technology or landscape. There's like all these different points in between and outside and adjacent to that. And so, yeah, it's really, really great. I'm glad you asked the question because that's something that's
Cindy Sanders, in one of our courses at Penn, she said something that stuck with me. Like, it's good to be a specialist in something, and be that one person. Like you said, with AI just opening up the playing field, you could really pick one thing or be a generalist and like have all the tools at hand. I actually take a lot of pride me calling myself a Swiss Army knife, but this is one space that you're giving me to like learn, and something that you've developed, that I could specialize in as well. So I'm
yeah.
thankful for that, and well, today we're going to talk about one of my personal favorite projects. I hope you're ready.
I hope so too.
Um, I'm going to share screen one here. We're going to talk about Monk's Garden. So, Monk's Garden is one of those small spaces. It was designed by MVVA. It's actually really narrow. It's 55 feet wide by about 175. So it's like a 1 to 3 proportion. And it's incredible what they achieved in this small space. Michael Van Valkenburgh obviously has made a name for itself doing big, large scale parks, including Brooklyn Bridge Park, but Michael likes to pick these like small garden projects to really explore ideas and test them as a lab. And it's nice to see that juxtaposition across their portfolio. And have you been to Monk's Garden?
I haven't been in person, but I'm familiar with the project. We've had multiple folks bring it up. It's such a cool
It's
project,
it's incredible what they jammed in there, and it's one of those projects that I would love. I'm from New York. It's one, so Boston is far, but I would go every season, to see how it changes the birch, the cinnamon birch, all the textures and foliage that they did is incredible. And I highly recommend people look at this book, Designing a Garden. It's a publication that really unravels the whole process from planting, paving. There's email threads of Michael to the client. So it's a very personal book. And the garden itself is a very simple concept. It's this walk that you go on that iterated through models. This is another thing that I wanted to touch on is MVVA is a very physical model firm. They test out with plan but the models that they build, it takes they invest a lot of time in studying these things in large scale physical models. I actually worked at MVVA for 2 years coming out of Penn. And for one of the public meetings in Toronto on the Portland's project, we built this massive model across the whole summer. Like these are 30 by 40 foam core boards. I don't remember how many they were, but we worked an entire summer on them. And it's interesting. Another point that I wanted to talk about is just like the different ways of working. And, MVVA is very big on the physical model. And here we're talking about the digital model. And I just wanted to get your thoughts on that duality and your experience, because you're also a sculptor, from what I understand, an
Yeah,
artist.
I have
And
an art background and originally thought I was going to go into sculpture, and started just realizing there was all these different things I could do. I got into 3D modeling and you know, yeah, but yeah, I think physical, and I did a lot of physical models when I was at Olin. I would spearhead building models. We did some really fun models and some really, really, I don't know, difficult models like the Metropolitan Museum of Art Plaza, where we hired somebody like a really serious fabricator to work on Alexandra. Yeah, amazing what a model can do and communicate to a client. And for a design team, like if it's like a working model, LandKit definitely has that spirit, of it is a digital model, but in a space like Revit,
yeah,
it's like everything is so
yeah.
constrained technically, and we still have there's always going to be technical limitations within a digital space, but being able to kind of be fluid and work and
Iterative.
have the advantages of some of the advantages anyways of a physical model by building it as a 3D model and be able to look at it from different angles and but not treating it as so precious,
Going
and then
going
on the
back to
other
that point
hand,
of,
yeah.
yeah, Revit or documentation, like you're usually doing that process to get to an end product. I think what LandKit has done is like it gives you all those byproducts, the sections, the views, the analytical stuff, cut fill analysis, hydroanalysis, paver quantities, and it really opens up the space to design. And that working model, as you're saying, that is very analog and physical at MVVA, you've completely transcribed it to the digital world, and it's less about producing a physical model, a 3D model to get a view of a project, and it's more about the process, which I love.
Yeah. Yeah.
I love the process.
I'm
Um,
sorry I rolled my eyes. I was just saying, like, I didn't mean, I don't know if I've completely transcribed the physical model
no,
making
no, I
process.
don't want to belittle
Yeah.
this. There's
No.
still magic in the analog, and something that,
Yeah.
as humans we gravitate to seeing a physical model.
Yeah, but if you think about like there's a physical model is great and everyone's like, I love physical models. They're great or whatever. And but sometimes they're not practical.
Yeah.
Like 3D printing out all these pieces or like even just printing out all these boards and just having the space or whatever, sometimes
Yeah,
it's
you
just
need
not
the
possible.
space.
Sometimes
Yeah,
it's
yeah,
not possible.
yeah.
It's like it's a messy process. And I'm not saying it's not valuable. It is very valuable, and that's why people still do it despite the cost, despite the time
Time.
and whatever, the
Yeah,
effort, the cuts on the fingers and all that stuff. The blood, the sweat, the tears. The digital model has this ease of this expediency to it, which is really helpful. But it also, when you combine that with computational design, which is what
hmm
kit crashing is, it's all about kind of like saying, what are the ways that we can use the tools and build stuff from scratch, right? How do we actually build a workflow that is specific to this project? That that is I think a really powerful skill that really drove the development of LandKit in the beginning. And we've been really focused on usability, and doing these other workflows that we have that are kind of like mini app versions of LandKit. But the flexibility of being able to build something up that's customized
right.
still has like incredible value. And there's a lot of folks who go to school and learn how to do this stuff and end up at a firm and never get to do that because it's too
hmm
too hard to kind of get over that hump of like I need to go from being like a beginner to like almost past novice to be able to
Yeah.
do much with this stuff. And we're hoping that LandKit can really help accelerate that process. It doesn't make it instantaneous, but it accelerates it quite a bit and makes uh, the pro user like really be able to do a lot, you know. And it's all about just kind of how do you put these operations, these landscape operations together and build something that is unique. So yeah, so hopefully we'll show a little bit of that today. I love these like little paving studies where they did all the individual pavers individually. I feel like that was something you and I hadn't really talked about before that I think could be fascinating to look at. So,
Well,
wow.
I mean, the reason I also think it's exciting to talk about process and just the book covers a lot of this. So I wanted to share that. There's actually a story in the book about a summer intern that took this tapestry that was in the Isabella Stewart Garden Museum and pulled it out, and this became an inspiration because initially it was just one unit and they had tested the scale, which we could do in LandKit. You could iterate whether it's a running bond, a herringbone pattern, but that led the team to like think about this dual tone and how we could recreate that in using LandKit. But the process was to take this idea and mock it up on site. Again, going back to the time and
Wow.
budget, like on this stuff, they would mock up the condition, which then informed the CD set and the final product, which no one can deny that it's exquisite, but there is
Yeah.
a lot of technicality and resolution in this project. And I just want to take a second to explain some stuff that I've learned working over there. There's, curve one, curve two. Each one of these is precise with point of reverse curvature. All of these then get put on a table with the dimension of every single curve. The curve has a, center line, which then varies from 4 feet to 8 feet to then 2 foot 8.
Mm.
Somewhere over here, it gets really tight and then it flares out. There's a lot of dynamism in that like walking path that they achieve. Sometimes the curves just touch. And it was a very late laborious process. And what I didn't know is that it's actually really complex grading wise too. I thought it was flat. And
Yeah.
but actually, you come in at 16.75, and the entrance is at 18.75. So it's 2 feet higher, which if we were to take, an ADA slope, we need 40 feet of run. So, and the thing is 50 feet wide. So not only did they achieve that, they did a bunch of like operations. Here they came up to 17.5 to go back down to meet this path that went up to come down to flatten out to this point where they kind of touch. Then they go back up to 18, so they're kind of at the elevation of the entryway. And then they go up even higher and have this like vantage point at
Mm,
20, and then you
nice.
circle back down. And so like there's just so much artistry in this project done, and they're really adios mio. I have nothing to say. It's just magical, whimsical, and where I would start, just based on what I know of Landkit is this center line and
Yeah.
playing with that center line, the pave
Mhm.
along path, which the workflow gives you the ability to play with the path width. This is something that Ben covers in our onboarding workshops. But last year you released the 2.1 update and you gave the flexibility to start introducing custom slopes because nothing is designed with the one slope meets all criteria.
Yeah.
And then in terms of this like snake-like skin, I was thinking that maybe you could use these like attractors to tr get that idea, but that's where I would start. And then, the whole grading of this project is just another beast of its own. But we're here to see you work your magic, and I sent you the two screenshots of the paving and grading file.
Yeah.
So maybe before we even jump into Rhino, what would your process be?
Oh my goodness. Well, I think probably the biggest place to start is the paving. It's two-dimensional. It's complicated as it is with these curves and like
Right.
that's the thing that I'm like, how does this kind of come together? And I usually I I like to attack the hardest thing first in a way because if I fail at it, I can fall back to other things and then let my brain work on it and then come back to it. If hopefully that's not what happens. We'll see. Maybe I'll nail it. Maybe I won't. That's part of why we call it kit crashing. But I think yeah, it's I would start, I know I say, oh, like we need to design in 3D, but a paving pattern is very much a 2D thing, and
Right.
and it's a two-dimensional system in many ways, and so we start there. We should define that plan, and we're in my case, we're going to just start with what they've designed. Like we're not going to start from the beginning of their process. We're just going to
No,
show
no, no, no.
how you could create something like this, and then probably be able to show how we could tweak things, right?
Adapt
How
it.
could we modify those things? So yeah, so that's probably how I'll start out, and then I'm trying to think. I just thought of something that might be a help to us. So yeah, so shall I start?
Yeah. I'm gonna lower the blind here so I
Okay.
don't get this two-face.
Oh, here, let me share my screen. So, unlike some of our other episodes, I started a little bit of setup. I just grabbed an image from online, and you sent me a little bit better image. And what I started doing was just drawing. I know I'm not drafting these perfectly, but the idea here is that this is the phase where we want to be able to move things really fluidly, and drafting exact poly arcs is
It's not important
antithetical to that.
right now. Yeah.
So what we'll do is we'll say, okay, we have the main parts here. We've taken an image, brought it in relatively to scale in this case. We have, a layer with some center line curves, and I'm still trying to wrap my head around how we're going to do this. I have this boundary curve that's going to kind of limit where the pavers go. And I have to kind of think through that a little bit. But I had another idea about how to do that. So I might just delete that. We'll see. Um, we'll see. So if I hmm, I'm just trying to think. It's tricky because we have kind of like two classes of path here. We have this path here has a constant width throughout the whole
Yeah.
path. It's as far as
Constant
I can
center
see it.
line. Yeah.
It's a center line. It's not changing in width, but honestly, it's the exception to the rule. All of the other paths are changing. So
Yeah.
um, I think what we need is a boundary for every single path. And this one included, even though it seems redundant, right? Like I know we could create a path procedurally with that one, but I think probably every single one of these is going to want a boundary. So I'm actually going to delete this boundary, and there's a reason. But let's start here. Let's start with, um, I'm drawing on the pave path CL layer. So we'll go over to Grasshopper and we'll do, um, actually, I'm going to drag my Grasshopper file in so I've got the naming all right. And I'm not going to use Elephant. This is kind of an old template. Delete that and delete these. Okay, so hit save. Yes, save as the new Grasshopper. So we're going to do a layer called pave and path
Pass.
CL,
Uh,
and then we'll do layer pipeline. We do a lot of this because I like to do this because it brings stuff directly in from Rhino, and then that way we can work with these geometries in Rhino and they come in automatically.
the
So
asterisk was when we want everything under that heading
yes,
label, right? Okay.
you want a wild card for say something like areas, like if you're bringing
Okay.
in all the different areas underneath a parent layer, you'd use the asterisk as the wild card to say anything past this that has any other naming or any other,
Okay.
text. So you can see that it's green because it's selected. And I may, just so that we're not going back and forth like crazy people, I'm gonna combine these two windows. Um, and then it automatically brings in all geometry, and we're only going to draw curves on this layer, but you can filter it and say just curves. So we can filter and say I only want curves. And then we're going to do pave, or sorry, path, add path pattern. So it wants one of two things. It wants either an area or a path. So this is kind of a neat thing. If we're going to build, um, if we're going to build paths like you were showing with grading, which we may need to do down the line, we may want to build this with paths and not with areas, which is kind of interesting. The only problem here is that we need it to have a custom outline,
Hmm.
right? So we may need to separate that. If you just have a straight path going up a hill and you want to pave it, you can use the same path to pave as you are to grade, which is
Right.
kind of cool. So it's the path kind of works for both. But in this case, I think what we want is an area that defines a certain zone and then a center line that defines the center line. So we'll start with the center lines first. And I think it's not happy because we haven't given it boundaries. So the next thing would be to give it center or boundaries. So the way I'm going to do this is I know that this is a 4-foot path. I'm going to offset this 2 feet.
Could you
And
script that though? Could we
I could if all the paths were
the same?
the same, but they're not. We need these custom boundaries, and that's what I was talking about before, that we need I'll actually delete this. I'll draw a line here. We
So
need
cl
custom boundaries for each one. The only one that seems like, oh, you could script that is this one, which that's
okay.
like one of the simplest things you can do with you know, Grasshopper is taking geometries and making simple transformations. Like, okay, I'm going to offset
Mathematical,
it this
right.
way, offset it that way,
Right.
and then all those are going to get lofted.
Right.
If you have multiple curves, then it gets a little bit more complicated because you have to think about the data structure. But in this case, we're going to focus on custom shapes for each center
I
line.
see. Okay.
Yeah. And there's another thing that we're going to do, which is to we're going to have to pair the boundaries with the center lines, which is a little tricky, right? Like, how do you do that? How do you make sure everything is set properly? So I'm going to grab this. I've drawn. I have three curves. I'm going to say join, and then I'm going to say close curve, and that's a fast way to kind of get a closed
The
boundary.
opposite end. Nice.
Yeah, it's great to know how to do that for people who don't. Um, but we're only doing it once for these paths. So then the next thing I'm going to do, originally I thought I needed to offset this, but I have an idea. So I'm going to say um, interpolated curve, and I'm going to draw this right exactly along this edge, I believe. And I don't know, I'm gonna have to explore this a little bit, but for conceptual purposes, this is a great way to prototype the idea, right? Um, Even if this doesn't reflect their construction documentation perfectly, and this is going to give us a really good, um, you know, pretty good representation of the design idea. So we come around the corner here and we begin to taper down. And I don't know, we can always adjust this curve as well. So then I'll follow this tightly and plug that in. Okay. So now we have at least two boundaries, which is like the main thing, right, for setting up our grasshopper is really just to have two boundaries. So I'll do this,
Another copy
make
changes.
another, yeah, another copy, and this is I like to or arrange the data so the wires don't cross. It's like Ghostbusters. Um, so then I'll do paving, and in this case, the bound it's called. Hang on, I got to get out of here to expand. It's called a lot of layers. It's under paving bound or path bound. We're going to say path bound, and we have our boundaries, and there's two curves, and there's two curves here. So what I will do is create an area from each of these. That's what we need. But we don't know, we don't know if the order of these geometries is the same as these.
Right.
And we could keep going in and like selecting them in order. Like that's one way to do it. It's kind of fussy if you don't know how to like set up some sort of thing in Grasshopper to solve that. You can do that. But I like to set up things that have a little bit of resiliency to them
Relationship.
so that they automatically fall into place. Or automagically, right? Um,
I like that
so,
word.
so yeah. So what we're going to do is say, give me the middle
Right.
point along each curve. And then we're going to say, is the curve in, or is the point in a curve? So what we'll do is we'll graft this data. And grafting just means like if I have a list of data, right? Just a list
Makes
of
separate.
items. When I hover over this, I can see this list. When I graft it, it says, oh, each item becomes
Is
its
its own
own
line.
list and that or a branch on that list. So then plug that into there, and I'll plug this into here. And
So
this
P is the
basically,
point and C is the curve. Okay.
yeah, P is point, and I didn't graft it. I explained grafting and I didn't graft it. So we plug that in, and now that's grafted. So it shows that these are two
Two
lists with
value.
their own addresses, basically, their own, that 000 and 000, sorry, 001, those are the addresses. And then what we get are two branches of results saying whether or not the curve appears or whether or not the point appears in all of the curves. So what we'll do is we'll say call pattern. We'll remove the geometry according to this pattern. And what it gives us is one curve. So if it occurs, it keeps it. If it doesn't occur, it deletes it. And I think that that should work. So we'll see. We'll see if it works here in a second. So then what I want to do is flatten this, and now all that data should be in the same order as my curves. Uh-oh, what did I do? Oh, wait a second. So the areas, I'm a little confused. This is giving me, oh, I actually need this geometry. I'm culling the boundary curves. So what I do, let me draw it here fast. So I say I have this point and this point, and I'm like I said, I'm
Which is
grafting
the
them.
center line of the boundary.
Yeah, from the center line. So these points, right? And then I test against this boundary, and then I do it again here and here. And this says,
Right.
oh, it's in here, but not here. And then this one
Yeah.
says, oh, it's not here, but it's here. And
Hmm.
then I say, okay, zap anything that's not in, and then flatten it. But in order to zap it, I need to say, okay, give me the list of those, give me the true false and zap them. You know, you use the cull, it's cull by a pattern. So it's
Hmm.
removing stuff that we don't want. And once we do that, we now have this guy and this guy, but then we need to flatten those back down so that they match the point list, right? So now we have the boundaries that match the points.
Hmm.
Um, Then, so that should work. And then we can plug this into here. And now we have areas. And we have paving. Houston, we have paving.
Amazing.
So what we want to do is look at the width of the paving. So the width right now is like crazy. It's 1 foot, and it looks more like it's going to be 4 inches. There's a couple ways we can do that. Because these are in inches, I'm going to say create an
Divide by 12.
expression on the input. So
You've
like
done
you
this
can just
before.
like you can do grafting here on the input, I'm gonna cha modify what that input is and say that the width is, you know, x. It always does x divided by 12, and that turns feet into inches. Is that right? Yeah, that's
Yeah.
right. Sorry, inches into feet turns the 4 inch into a foot value. So now, oh, that's path width. I want paver width. So we do um, x divided by 12. And
The length as well.
yeah, and this is wrong. First of all, we don't want this expression.
No, because that is going to be a number in feet.
Yeah. And then in order to, sorry, commit. There we go. In order to remove this, we hold the command or control key down and we just replug it and it unplugs that. Now our path width, we know that the width is 4 feet in this, well, at least in this case. This is going to be an issue here, and we're going to address that. Um,
Why isn't the boundary supposed to be the edge?
I'll show you that in a minute. I'll show you
Okay.
in a minute. Yeah. Um, so if we say, for the length as well, we need x divided by 12. And our length looks like, I don't know, maybe it's 8
Yeah, like
inches, right?
2 to 1.
As I go along, I like to hit save. So that's good. And then there's probably some kind of spacing between them as well. I'm just going to do 0.01, which is in
Something
feet.
which you would never draw in CAD, which
Yeah,
this I love already.
yeah. Um, and then we can just, we can adjust that dynamically. Yeah. And you could do that, do the expression on that as well to be x divided by 12 and do a inch value. So let me look at what your question was regarding regarding the boundary. So why is it not, adjusting according to the boundary, right? And part of that has to do with the fact that we are giving it an exact paver or path width, right? So the path has a a width, and different paths are going to have different widths. We know that. That's going to have to adjust. Um, and so we may need to do our custom parameters possibly. Or we could say, well, just make it big, like just make it bigger, and then we'll remove pavers from that boundary. Um, and so, um, so what we want to do is we can trim, like there's a few ways to deal with this. One is to trim, right? So we could say pavers and just trim them. And it's trimming a lot of pavers. So it's kind of a kind of a slowish operation. Now we have pavers that are getting trimmed along those boundaries. It's a little
Where
hard
are
to
you
see.
giving
Let's
it the area? Where did you get so the trim works without it knows based on the relationship behind in the script that it's to the boundary. Ah, no, it's based on the center line. No, it's based on the boundary. Like
It's
I
space.
find
It
it in
trims it uses the boundary to trim. But what we're going to do as a trick, as a hack, is we're going to say, you know, um, hang on, curve. We're going to plug in the uncut pavers, and then we'll hide this. And now, and it's hard to see, so we're going to do a mesh just so we can see these and hide this other stuff. There's a lot of stuff going on here. And then we will plug this into maybe some kind of a preview bake plus. And then we will make this, I don't know. Yeah, that's close enough for now. So now you can see that it's getting much closer to what we need, right? It's only including pavers that are not trimmed. Um, there's definitely some issues with our width, right? So if you have a 4 inch wide, what is it? Yeah, 4 inch wide paver with a gap,
yeah, yeah.
and then you have a width of the path,
You
which
have
is
to
only
account
four
for it.
feet, it's not really
Yeah.
going to fit, right? And this is the kind of thing that typically you wouldn't discover that until you're maybe in
Exactly.
the field or like the
In the
contractor's
field,
like, this doesn't
right?
make sense or whatever. And that's why you do those tests. But in our case, what we could do is we could just say, oh, like we should have made this offset bigger, right? Like we should have, and we can actually just do that. We can say, okay, well, my width is going to be, let's just say that we've decided it's 0.02. We can say offset, um, I said 0, offset um, zero point zero 0.06, right? Because we're going to have a gap or point 0, let's just be say 0.08, because it's not gonna.
It's the number of gaps between all of these. So it's one, two, three, four, five, six, seven, eight, nine, 9 times point
Yeah,
zero
but we're
two.
offsetting on both sides, so it's only half of those.
Oh, so four times eight. Yeah, so eight.
So 8, I might just do just to be safe because it's forgiving up until like the next paver, so it might as well just do 1 point or point one
Point
two or
one.
something.
Yeah.
And then I'll delete this. Oops. I'll delete the old one. We'll see. It's probably not going to be happy. Uh-oh. I'll delete the old one. It's going to have to retrim. But yeah, that should do it.
While we wait, what I was getting at is the trim component in Grasshopper doesn't need the boundary curve. It recognizes it from the step behind, is what I was trying to understand. you put in the trim component and you didn't plug in the boundary. It's already
The boundary's
inherent,
in there, right? You don't have to
right?
trim. It's like yeah, it takes the logic. It says, hey, whatever the boundary was, use
Yeah,
that.
so one less wire.
One less wire, exactly. So we're already kind of like really starting to get to um, I can like extend this out to here. I know this is not following the curve properly, but um, you know, we can begin to see that we can just like just as a conceptual thing, this is probably, I don't know, a little undesirable in terms of the process, I would say. Um, there's also something about the way that I'm just noticing, oh, did I draw 2 points? I think I drew two
Yeah.
points. That's funny. Um,
And just flagging that you know, we're dealing with a lot of geometry here that's being drawn and modeled, which is why it's starting to slow down and
yeah.
bog.
Yeah, but I
But it
mean,
gives you the pros of like visualizing this in real time and controlling the gap, iterating the curve. It has its pros, obviously.
absolutely. So one of the things you'll see, like if we look here at the preview, can you see how it's like simplifying that curve a little bit? See how it
Yeah.
like the green doesn't quite meet the purple curve? That's because when you create an area, you can set your own tolerances. So we have a distance tolerance of zero point zero 0.01 feet and an edge tolerance of 5 feet. So if we wanted
Mm.
to tighten that up, we could do 2 feet. And it's just going to be a lot tighter. And it might actually, so what was happening is that shift was, it seemed to be cutting off some of those pavers. That's interesting. It's still doing it. We may just want to offset this a little bit more, that
Mhm.
because you don't want to make this too detailed because then it can start to be a little bit heavy. We don't want, it's this kind of back and forth of like, we don't want it to be too heavy. You want to be able to iterate and all of that fun stuff. Um, so, so let's take that curve. We're still on the path boundary. We'll offset it. Oops. We'll offset another point. Um, how many feet?
An inch.
0.04 or something. Yeah, something like that. And then we have to click to offset it, and then we can delete the old curve. It's the way that it's working, it's processing both changes. So like once we make the offset, because it's in the layer pipeline, it pulls that in. And then when we delete it, processes it again. That's why the wheel is spinning there. But you can see that we have a pretty great approach to this in terms of
Yeah.
how we can begin to iterate. And then we can take this and say, all right, take all these points and maybe we're moving those, just maybe we have a sketch that the boss drew and we're just trying to kind of match the sketch, right? And we're kind of like, let's get it as close to what the boss said as possible. And we'll move that curve up and it starts to fill in those gaps that we're missing. We grab this and we say, yeah, this is actually a lot of points. And the reason it does that is from the offset. So what we could do
Mhm.
is say simplify curve. Um, and sometimes that will do it. It doesn't seem to be doing it in this case. But what we can do is, just fix little things like that if we needed to. I don't know if that's going to do it. Yeah, it did it. In this case, it did it nicely. So pretty good. Maybe, if we look at this, it's not, pardon me, it's not construction dock level, but
No, but
it's
we did this in 20
we
minutes.
did it in 20 minutes. Um, so the other thing to look at here is the way that the pattern starts, and this is just like a little side thing.
That's
So
what I was gonna ask you about this.
yeah, there's a start mode. So it starts with a running bond. And ironically, once we get to here, you see this kind of like everything is sort of stacked up,
Aligned, yeah.
right? And that might be undesirable, and in some cases unavoidable. It's just, when you're shifting the width, it's gonna change, and things are gonna line up. You can do for these start modes, you can do none, um, which is I think ran. What is none? I forget what none is. Why would there be none? Running bond, random, and seams. Oh, these are modes. So so random. Let me see. So none. Let's just try it. Zero is. Oh, none means like it starts with no running bond. It's like everything is lined up perfectly.
Aligned.
Yeah,
Okay.
yeah. And then we saw running bond, and then the next one is random. So we start there, and you can see that what it will do is it will randomize the
The
starting
start point.
positions of each row. And that might, in the grand scheme of things, even though certain things line up a little bit more, it's not like this thing where you're like, why are all of those lined up? It's conspicuous, right? And you don't, when you're doing this visual design, sometimes you don't. That's really important. Um, and then the other mode is just since we're here and doing it is three, which is it does kind of a um, what is it doing? Seems, I forget. I feel like seems it needs a path, and seems will actually turn it into kind of like a boardwalk. Like it'll turn it into a um, like an edging condition almost. So let's just plug into call it quits on this little element here.
Two is running bond, right?
Yeah. And so, you can see that we have an expensive component, right, in terms of processing. And the way that I noticed that is I'm using what's called the
I
profile
like
with,
the name expensive component.
yeah.
4.4
Um,
seconds is expensive.
yeah. And I don't mean like the cost of the software.
No, no,
Um,
no. I thought that was
um,
great.
yeah.
Time. Time
So, but it is valuable. It's
yeah,
valuable.
time is valuable.
So if you go to the settings, if you're in, you got to be in Grasshopper. You go to the settings and say Grasshopper settings, and there's all kinds of different stuff. Some of these are actually Pancake. That's like a plugin. But widgets lets you go under widgets. You can go down and say turn on the profiler widget, and what it does is it shows you how fast each component is running. And it gives you a little color indication too, which is really nice. This is for anybody who's doing serious computational design. This is really important because you start to see what takes a really long time, what
Right.
geometric operations take a long time, like maybe where a problem is occurring because you've grafted where you should have flattened data or something like that. Um, yeah, and so you can see that you're multiplying.
But this is where I mean, not to derail the conversation, but this is where the value proposition of LandKit is really in your face. It's like 711 milliseconds to create all of that,
Yeah, yeah,
or 4 seconds to like, you know how long it would take to draw this, and your boss comes back and is like, I want this arc to be tighter, and you're arraying a rectangle.
yeah. Sorry, I'm just like setting up this last curve. Anyway, so I can extend this curve, and maybe that's what I'll do. I'll say use this as a boundary,
Yeah.
extend it, and do an arc. So arc is the type that I'm using. So then when I click on this and I go, oh, it's going to follow it. Let me see if there's a different way to do this. Smooth. I thought there was oh no. I thought there was a way to do this that that you could actually determine how to do that. But this brings up a different interesting point, which is if you can see what just happened there, I'm going to undo that. But some of those early studies you showed me, right, of how they were looking at the pattern and how it landed on the path, we could just as easily say, oh, like what if, we did this thing where like the pattern kind of like falls off of the path, and so it begins to turn in a different way, and then and we get this, this kind of thing. And who knows, maybe they would have done something more freewheeling with, things kind of going in and out if they had a tool like this, right?
Yeah, because it
Like if
starts
they
to give
had,
you
if,
that jagged edge that they ended up doing.
yeah, a lot of times the decisions we make about these things, they have to do with constructability, but they also have to do with
Mhm.
like, what can our, oops, there's my thumbs up. What can our team do in the time that we have? Like what's possible to document? And if you're like literally, if the tool is literally helping you draw this thing,
But
um,
I mean, just to stay here, just to
yeah, sorry, let
sketch
me
this
pause.
through.
Hang on,
What
I'll stop moving.
zoom out?
I'm done.
Yeah, someone. I mean, we could. We don't have to do this, but the theory is there. Like we could play with that boundary and move like you did, and you would get that, jagged edge here. It's the
Yeah,
same. So it's just a lot faster because I would always think of it as the center line, but what you just did there gave us the effect that they wanted to study and iterate, which was like how far does it start to peel if we zoom back out?
yeah,
Like there's those are the most beautiful moments of the project, I think, is when it flares out and then the edge dissipates and it's not a clean offset like
yeah.
this condition right here. So you just showed me a really fast way to iterate that.
So I'm going to show you something even faster here. This is all about speed. So you can see
Yeah.
this takes 4 seconds. So every time I do something in the file, it's like I wait 4 seconds. Doesn't seem like a long time, but when you're working and you're in the flow, it's like it's really hard because you want to be able to edit a lot of things. So if I just lock the solver, I can then go and say, all right, let's draw an arc. Oops. Make sure you're in Rhino. Let's draw an arc, and I'm going to do T for tangent, and then I'll go off of the end of this and all the way over to the end of here or so, and then I can,
Pick the third point. Yeah.
yeah, pick that third point. And I don't know where it is exactly, and then I click there, and then I can take, yeah, this is not quite right. Um,
Circle TTR, I think I would use.
I think that's a CAD command, isn't it? Circle
Circle.
TTI. I just have to look and see which curve we're on. I think it's this one. Huh, that's weird. Anyway, I'm just trying to extend the curve is all. But if I select this curve and then this curve and I say join,
Join.
and now we can unlock. We'll just also just check to make sure they're on the right layer. But usually if the last thing you select, if you say join, it'll join and it'll become part of that layer. And then here we can unlock this, and you know, things are starting to look a lot closer. And sometimes it's good enough for a rendering maybe, or it's
Yeah,
good
yeah.
enough for a quick, design study. Um, but we can expand our you know, our scope here to make it so that we don't have missing teeth at least. And the neat thing about this is we can refine this into into a construction document, right? Like we're just tweaking things and we're just refining and saying, hey, like how do I want this to work, or how does the boss want this to work? You know, um, yeah. So we have that. So that's the pattern. And let's look very quickly at the colorways. right? So there's a few ways to do this. One is an image color rule, and another is like
I
an
see.
attractor color rule. There's a few different
You
ways we
would
can
you
do
would
it.
bring a sketch and just have like these blobs and it would start to populate based on your sketch.
Yeah. Yeah.
Good idea.
So, um, what was the um, they were using a tapestry, right?
Yeah.
As the basis. Um, let's do this. Let me grab this image and I'll pull this into here. This is a tapestry. Oops. Got a tapestry. I'll pull this tapestry into here. I want to make sure that it's not overriding another image, so that's why I need to put it here. And then I'll do like this. And then, it's like a tapestry, right? We'll take that image. I'll put it on well, let me reference it first. I'll say surface. Just going to right click and say set one surface. For individual geometries like this, I don't like to use the layer pipeline as often, but you can do that. I just, in this case, I just want to reference that. And then I'm going to put it on its own layer. So we'll say tapestry image. We'll change this layer. We'll hide this. And then I don't want to see this either. Um, preview, go
Interesting.
turn preview off. So I'll say save. What we're going to do is we have a few odd things here. So whenever the trim paver tool cuts out pavers, the area that continues forward is the exact trim, right? But we have this special output of cut and uncut pavers, and we're using this special case. So what we can do is we can make um, we can we can take the area that we had before we filled it with pavers, and we can fill it with custom paving. So we'll take this set of pavers as a pattern, and then these areas. One thing that you can see though is that, see that dotted line? That dotted line is saying that there's two branches, basically. It means that there's multiple layers of data here. There's two
Because
layers.
there are two areas.
Yeah. And so if I plug in the areas, I'm going to have this two things in one list versus, all these things in these two lists. So what I really need is I need two branches for each set of data. So what we'll do is we'll branch this. We'll say graphed so that when we plug the areas in, sorry, sometimes we get in this little click loop. When I click there, it now is going to apply these pavers to this area and these pavers to that area. And then I can,
What was this component, Chris? This last one with the
this one,
waves? Add
add
custom
custom
pattern.
pattern. And the neat thing about that is you can add any curved geometry as a pattern to your area, right? So that could be some crazy thing that you've created. We could even, like, I could do this and I could say, this is going to be insane, but let me see if I have a fillet. And I do, this is probably going to explode my computer. I'll just say save everything. I'll plug these uncut pavers into here. I'll give them all radiuses, right? So now they have nice radiuses, and then I plug those into here. So now I have this really customized pattern, right? That maybe looks even more. And I'll plug these into here just so that we can see that reflected in our preview. So that you can customize the pattern that goes in, and you can take our standardized patterns and pull out the pavers and do stuff with them, or you can create your own pattern using some grasshopper thing. Now, once I have that, I'm going to create a image color rule. An image color rule allows us to take this surface that has an image on it, mapped to it, plug that into the picture, and then we're going to add a color rule to the area. So we say add this color rule. And now each of those areas has a color rule. And if we're going to move this down because it's going to get replaced. We're going to say draw the area. With that, we now have a few options to draw different, we have different options. So we can do colors. There's the type of thing we're outputting, the thickness, if we're doing a certain, something that has, pavers that actually have width. But I'm gonna just create a swatch that's white, copy and paste that, and change the other one to gray, just so that we can do our two colors. I'll create a merge component. I like to do this to avoid saying like I can plug this into here and then hold shift and add that, but I always feel like that's just like trying to manage that if there's more than a couple inputs is always really wacky. So I prefer to use the merge. And then we want to visualize that. So we're going to take the pavers and plug that into here. That's going to look very similar because we haven't changed anything. But then the colors will plug into here. And now we can see that this thing is following the tapestry image. Let me hide these first. So if I turn that on, I can see that it's actually turning the light areas into dark colors. And the reason that happens is because if you think about it, a dark color is a lower number, right? And so what we actually want to do is, move this dark gray to be the first color if we want it to reflect that image more clearly. Oops. I don't know what I just did. There we go. I plugged gray into the white. So now we can see like that's the horse's leg there, or the horse's tail. That's the tree. Yeah, so it's not the most dramatic image. We might want an image that's more like spots. Let's do this one.
But I mean, here, let me send you this image because it's
Oh yeah, do you have one?
yeah, their image. Because
Their
I'm
image.
thinking
Okay.
about how they would have done this.
Are you sending via email or?
I'm just gonna take a screenshot because I don't know how to do this fast enough.
Put it in the chat.
Yeah, we'll cut this part out.
It's all right. It's part of the fun.
Google Chat.
How far are we in here? Maybe we do the grading in another episode here.
No, it's way too much for one.
Yeah. Oh, that's their actual image. Yeah,
But like
that's okay. I feel like
you could
that's
simplify that. And just conceptually,
yeah,
we
here
could
let me
sketch that in in a hypothetical world. I'm doing this. I would just like bring it into Miro and do these blobs, and I'm done. It would transcribe that.
yeah, so you can see oops, this is what we're seeing here. So the problem here is that the image has like all the trees and all the stuff, and what you want
Yeah.
is a really clean image, right? You want a really clean set. And so there's another way to approach this which would be to create an attractor color thing, and you could like literally draw shapes that
Right.
would determine the color. Like that's another way to do this. Um, but the other way is to have like a background of the image and paint the whole thing in Photoshop. So you can kind of like
Yeah.
really like, paint it all in or on an
That's what I was
iPad or
getting at.
something,
Yeah.
and then bring it in, register it, and then replace it with a version that doesn't have that background and just the black and white color. And
Yep.
it will be like a perfectly registered thing. And then you can iterate with that really quickly and in a very artistic way. Like you can work on the image and then just swap it out or different versions of it.
10 versions, yeah.
Yeah, exactly. Um,
No, but the
so
conceptually, I think that's very clear from what we've shared so far.
yeah. So I could say, all right, well, I just need an area of this image that's more interesting. So I can take this and bring it down here, and then say, scale this, like this, so that it's that pattern on the border.
Yeah.
Um, and then turn this off. And now we can see that it has these bigger shapes, right?
Blotches, yeah.
Yeah. And part of the reason that it's not like black and white is that that image isn't black and white. It's like all these weird in between tones. And so if you use an image, you may want to like adjust it to be more normalized to like black and white or whatever. I've also found that if you really want to control like super smooth gradients, you can use Illustrator to do like really controlled. You can do gra Illustrator. You can do gradients that aren't just like like a single
Yeah,
offset. You can
yeah,
do them
yeah,
to
yeah.
like create gradient fields and stuff.
Deformed.
I've seen some really neat results with that from some folks. So turn that off. Um, and really the all you have to do now is like iterate and come up with ideas for, drawing the rest of the shapes, um, having different pattern ideas, exploring a different wiggle to the thing or whatever. Um,
Yeah, but
I'm
the
trying to think
rules
if
are
there's
so
other,
limiting.
what's that?
But the rules, and that's kind of what we're trying to really highlight here is that I think the key word in kit crashing is process. Is just like we built in an hour a script that you can then iterate. Like we can now iterate the curve, we can iterate the boundary, we can iterate the
Yeah,
paver size, we can iterate the gap, we can the
absolutely.
um, there's so much to be done here. It's really powerful and saved countless hours. Like this is just it's nice to get under the hood and I love that book because of it because it really reveals the process and how much work. But going back to the conversation we had at the beginning, like this is a garden. Like there are very few gardens that firms are going to land with that kind of budget and time to explore those ideas. Like you have to get the project. Oh, the project, Renzo was building his building and the garden had to be ready and you're working against a timeline. Doing these studies, we would go down from the 16th floor in MVVA and go to the Cadman Plaza and mock up things real time. You got to have the time and budget and a client that's willing to pay for that. I
Yeah.
think that this gives you, going back to the initial conversation, which is why I wanted to have that with you, of the digital versus the physical. There's a lot of pros in terms of budget and being profitable as a practice.
Yeah. And like what you want to achieve as a practice, because a lot of practices they're like starting from like on small projects and they like want to show that they can do something great, but then that just takes just doing all this work that's free, and it's really hard. So we're hoping that, we can elevate those firms and in general, hopefully help to elevate the profession and the things that the profession can do with paving, with topo and performance and all those other fun things. It started raining out here.
And change over time. Another session to
Another
be had.
session. We got to get into water soon.
Yeah.
We got to talk water.
Well, I really am curious about the grading on this one, how because the topo and then sections, serial sections across this thing,
Mm,
just having that handy.
yeah.
So let's definitely continue this conversation next week, and then I'll go back to my list of projects. This has riffed off some other ideas. I might have to shift the priorities, but let's keep it going. Episode 5, solid.
Solid. Awesome. Thanks, Ishaan.
Thanks, Chris. Talk to you soon.
Yeah, see you soon.